Okay, let's unpack this. Welcome back to the deep dive. Our mission today is, well, it's arguably the biggest one there is.
The biggest one in all of science, really.
The quest for a theory of everything. We've got a mountain of sources here, all laying out something called the Unified Compression-Based Field Theory, or UCBF.
Right.
And we're going to try and pull out the core ideas, the insights that propose this. Well, this radical and fully quantitative answer to that huge puzzle.
It really is the ultimate unification mission. It starts by trying to bridge, I think, the single greatest chasm in all of modern physics.
You're talking about the big split.
The big split. For almost 100 years, we've lived with two frameworks for reality, and they just fundamentally do not speak the same language.
On one side, you've got general relativity. That's the universe at the largest scales, the cosmos. It's elegant, it's beautiful, it's all about geometry.
Smooth, continuous curvature of space-time.
Exactly, like massive objects are just bowling balls on a giant rubber sheet, distorting it.
And that's gravity, precisely. But then, at the total opposite end of the scale, you have quantum mechanics.
A micro world.
The micro world.
Yeah.
And it's the complete opposite. It's discrete, it's probabilistic, it's granular. Energy comes in little packets, fields are fuzzy.
And the conflict comes when you smash them together.
It's a disaster. When physicists try to calculate quantum effects, like the energy of space-time itself or, what happens inside a black hole,
The math just explodes.
it just gives you infinities. You get nonsense.
So we have a physics that works perfectly for the incredibly big and a physics that works perfectly for the incredibly small. But the second you try to build a bridge, the whole thing
Yeah.
it short circuits.
And that means our picture of reality is fundamentally incomplete.
Right.
And that's the core conflict. That's what the UCBF theory aims to solve. And it does it with a really radical shift in thinking.
Which is
The reintroduction of the ether.
Okay, hold on. When people hear aether, they're thinking of, 19th century physics. The old, static, luminiferous ether that was disproven.
And you should throw that idea right out. This has nothing to do with that.
This aether is something else entirely.
It's a hyperdense, elastic superfluid, a five-dimensional ocean that is the absolute opposite of empty space.
So it's the tangible stuff of reality.
It is the substrate.
Yeah.
And what we're looking at is a framework that takes the really complex, abstract geometry of string theory, specifically from 10-dimensional physics, and it maps all that abstraction directly onto something intuitive, something mechanical, hydrodynamics.
So it's a closed-form mathematical candidate for a theory of everything. We are diving into that quantitative structure today.
We are.
And before we get into the weeds, let's just frame the two biggest aha moments for you, the listener. First, under this theory, gravity isn't a pull. It's a push from this cosmic fluid. And second, that huge mystery of dark matter. It might just be the buoyancy of this universal ocean.
So let's start at the beginning, the core axioms.
Okay. For the last century, physics has basically told us that space is a vacuum. It's mostly empty. And the UCBF starts by saying, nope, reject that entirely. The fundamental idea is that reality is this hyperdense superfluid continuum, the aether.
Right. And you have to internalize the analogy here.
Which is that we're like fish.
We're fish swimming in an invisible, incredibly high-pressure ocean. We're not floating in a void. We are in something.
So what does that mean technically? What are the properties of this medium?
It means it's a physical, tangible substance, but one with such extreme properties that it feels like nothing to us. It feels null.
Okay.
And the sources derive these properties from the theory's fundamental constants.
Yeah.
The very first thing we have to get our heads around is its sheer density, its baseline density.
Give us the scale, because when you say hyperdense in this context, it's got to be a wild understatement.
It is. We're talking about the inherent energy of the quantum vacuum, but given a physical form. It's called the ether rest density, or ρ0.
And the number.
The theory locks this value at a staggering figure, 8.9, 1 times 10 to the 17, GeV to the 4th per c squared. Just think about that magnitude. This isn't some tiny, fleeting quantum fluctuation. This is the enormous, fundamental, baseline energy density that provides the entire fabric of the universe.
So every force, every particle.
They're all just excitations within this incredibly dense stuff.
That number is so big it's almost meaningless. But it raises an immediate question.
I know which one.
If the aether is that dense, why don't we feel it? If we're swimming in something that heavy, why aren't we just frozen in place? Why doesn't it feel like trying to walk through solid lead?
And that is the beautiful part of the theory. It's resolved by its mechanical properties,
Yeah.
its stiffness, and its compressibility.
Two extremes.
Two extremes. We perceive space as empty because, first, its stiffness, its resistance to being deformed, is quantified by the ether shear modulus, G sub A.
And this is a huge conceptual leap in the theory, right? It connects the stiffness of the vacuum to gravity itself.
It equates them. The UCBF asserts that the ether shear modulus is numerically identical to Newton's gravitational constant, the big G.
So 6.67 times 10 to the negative 11.
That exact number. That constant defines the elastic stiffness of the vacuum, how much resists being bent or stretched. The fact that the ether's own elasticity dictates gravity is the first major consistency check.
It has to obey classical gravity.
It must. And defining its stiffness as G ensures that it does. The medium is so incredibly stiff that it takes a colossal amount of energy, like a planet or a star, to cause even the tiniest permanent deformation.
Okay, so it's incredibly stiff, which explains why it resists motion so powerfully. But what about squeezing it? Is it easily compressible?
The absolute opposite. The ether's compressibility, kappa, is minute. It's cited as 1.2, 3 times 10 to the negative 38 meters squared per Newton.
Tiny.
Almost zero. So to change its volume even by a fraction, you'd need an astronomical amount of force. It behaves like a perfect superfluid, zero viscosity, so things can move through it. But any attempt to compress it or tear it is met with this profound immediate resistance.
It's a powerful mechanical picture. But this idea of a 4D superfluid doesn't just come out of nowhere. It ties back to the UCBF's origin story, which is rooted in higher dimensions.
It is, rooted in string theory geometry. The UCBF is built on the foundation that this ether isn't just a 4D medium. It's what emerges when you compress a larger 10-dimensional structure.
From heterotic supergravity.
A low energy limit of it, yes. And the geometry is crucial. The ether exists primarily as the 5-dimensional fluid. Our reality, our 4D universe, is just the boundary, the surface, the brain, as it's often called.
So we're literally living on the skin of a cosmic ocean.
That's the picture. And here's the quantitative link that makes it work. The UCBF identifies the mathematical field that controls the size of that fifth dimension. In these models, it's called the radion, sigma with the physical ether density rho.
So they're the same thing.
Mathematically and physically, they are one and the same. The abstract geometry of a compressed extra dimension is the tangible density of our vacuum. That's the bridge from string theory to intuitive mechanics.
Okay, so if the ether is this hyperdense elastic superfluid, the consequences for gravity have to be immediate.
They are profound.
So tell me how this redefines Newton and Einstein. The UCBF's biggest claim is that gravity doesn't pull, the ether pushes. Is that just a different way of saying the same thing, or is there a physically distinct mechanism here?
It is absolutely not semantics. It's a completely different physical mechanism. The classical view is that mass warps space-time and objects just follow the curves.
The geodesic path.
Right. UCBF replaces that with a purely mechanical, pressure-driven force. It's just hydrodynamics. Here's the core idea. Mass, in this framework, is fundamentally a localized zone of reduced ether density.
So a star or a planet is literally a pocket of low pressure, a slight void in this universal ocean.
Precisely. And what happens in any fluid system when you create a low-pressure zone in a high-pressure environment?
The high-pressure fluid rushes in to fill the gap.
It rushes inward to equalize that pressure differential. And that inward rush, that surrounding high-pressure ether pushing on everything, that is the force we call gravity. The medium is pushing you toward the zone of reduced density.
I have to push back a little, though. A pull or a push, doesn't it look identical to us on the ground? Does it really matter if the Earth pulls the apple down or if the ether pushes the apple down toward the Earth?
It matters fundamentally because this provides the underlying cause. Falling is explained purely as an object being pressed by the surrounding medium toward the low-density zone created by a mass. And there's a law for it.
An equation.
A very simple one. G equals the gradient of ether pressure divided by the local ether density. Gravity is just the force from the pressure gradient. It's universal hydrodynamics.
And what's really striking is that this pressure-based model ends up being mathematically identical to Newtonian gravity, at least on a planetary scale.
It has to be. And that's the quantitative verification. The source material shows that if you use this law and you plug in the ether's stiffness, which is G, and the known density and radius of the Earth, you get exactly 9.81 meters per second squared.
Wow.
It shows that mechanical replacement is mathematically closed. It's consistent with what we observe. This is crucial because it proves the hydrodynamic idea isn't just a nice story. It can reproduce the hard numbers we see every day.
That makes it much more compelling. And this pressure-driven gravity must be governed by something at the smallest scale of the ether itself, right? It has to connect back to the quantum world.
It does. To govern the fine-grained mechanics of this fluid, its compressibility, the theory introduces a fundamental quantum constant,
And that is the
the Brent Aether mass.
B sub.
What's the physical meaning of that?
BH is defined as the minimum mass quantum of the ether condensate itself. It's a tiny value, about 9.2 times 10 to the negative 3 electron volts.
So very small. Very small. But it's the foundational constant that sets the scale for everything. If the ether is a superfluid condensate, BH is the mass of the most fundamental, irreducible droplet of that fluid. It's the building block.
So it's the bridge.
It's the critical bridge that links the immense stiffness of the vacuum on the macro scale to the tiny, discrete units that compose it on the micro scale. It dictates everything from compressibility to quantum granularity.
Okay, so with the ether established as this fundamental hyperdense medium,
The substrate of reality.
right, the UCBF now has to explain the big one. How does this continuous fluid, which gives us smooth gravity, also account for the discrete, probabilistic world of quantum mechanics?
And the solution is in the Aether structure. It's not uniformly smooth at all scales.
We're zooming in. We're moving from looking at the ocean to looking at the water molecules.
That's a perfect analogy. So let's focus on the granularity first, the quantum scale.
So at the smallest of scales, the ether is granular.
Fundamentally granular. It's less like water and more like a tightly packed bed of superfine elastic sand. And the size of those grains is defined by that constant we just mentioned, the Brent Aether mass.
If the ether is a kind of lattice or a mesh at that level, that has to completely change how we view matter itself.
It changes everything. Particles, electrons, quarks, all of them. They aren't little solid marbles floating through the void.
They're what?
The UCVF defines matter as vortices. They're stable, complex topological whirlpools, knots of circulation and tension within the ether fluid itself.
So they're properties like mass or charge.
They're just manifestations of the flow patterns and the stored energy in the surrounding ether. For example, the theory derives electromagnetism as the circulation signature around these vortices.
That's a huge conceptual shift. You're trading abstract point particles for durable knots in a physical medium. Which brings us back to the hierarchy problem. Why is gravity, which is this massive ether pressure, so incredibly weak compared to the forces between these tiny vortices?
And this is explained by a concept called quantum slippage. Okay, imagine the granularity of the ether as a microscopic mesh, or a sieve. A single atom is so small, its size is comparable to the spacing between the ether grains.
So it just slips through the gaps.
It effectively slips between the nodes of the ether lattice. And if the particle size is similar to the grain size, the bulk fluid pressure can't get a good grip on it, can't effectively push on it.
So because the atom slips through, the massive background pressure of the ether, which is gravity, can't apply its full force.
Exactly. Gravity is essentially off at the quantum scale.
Right.
And this resolves a foundational mystery, right?
Mm-hmm.
Atomic structure needs incredibly strong nuclear forces to hold it together, precisely because the ether's pressure-based gravity is absent when an object is small enough to slip through the sieve.
The full pressure only shows up when the object is big enough to actually block the flow?
That's the key.
Okay, that slippage idea is a really elegant explanation for the quantum realm. But we know gravity is dominant for us, on human scales, on planetary scales. So how do you make that jump? From the discrete, slipping quantum world where gravity is basically off, to the continuous classical world where gravity is everything.
This is what the theory calls the coherence transition. And the transition happens not because some new physics magically takes over, but because the mechanical interaction with the ether completely changes.
It is out stale.
It's all about scale. When enough atoms clump together, when they form a macroscopic object like a grain of sand, or you, or me,
Yeah.
their collective radius eventually gets bigger than the spacing of the ether grains.
The object stops being porous to the ether and starts being an obstacle.
Correct. As soon as its size crosses that coherence length, it can no longer slip through the lattice. It forces the ether to interact with it not as a granular probabilistic mesh,
Which is quantum mechanics.
but as a continuous deterministic hydrodynamic fluid.
Which is general relativity.
At that specific size boundary, the physics shifts. Abruptly. The coherence transition is defined entirely by the scale of the object relative to the granularity of the ether.
So the line between the quantum world and the classical world isn't some arbitrary mathematical thing. It's a physical, mechanical threshold. It's just about how effectively something blocks the flow of the universal ether.
That is the unified picture.
Now, let's take this hydrodynamic view and scale it all the way up to the biggest structures in the universe.
Galaxies.
For decades, standard GR has had to rely on dark matter, this invisible halo of mass, to explain why galaxies rotate the way they do.
The rotation curves, right. The observation that stars on the edges of galaxies are moving way too fast.
Far too fast for the amount of visible matter to hold them in orbit. It implies there's a huge amount of unseen gravitational pull.
The UCBF offers a completely different explanation. It's called galactic buoyancy.
Yep.
If the entire universe is this aether ocean, then a galaxy is just a vast, diffuse, buoyant body immersed in this high-pressure fluid. And remember, mass creates a localized, low-pressure zone in the aether.
So a whole galaxy is a colossal, rotating, low-pressure system.
Precisely. And the ether, just by its own hydrodynamic laws, provides immense stabilizing pressure against the galaxy's rotation and its mass distribution. It acts like a viscous stabilizing force.
It prevents the edges from flying apart.
It provides the necessary centripetal force to keep those stars in their orbits. The rotation curves flatten out at the edges because the ether pressure is supplying that force.
So the effect we observe isn't caused by some invisible mass pulling from the outside.
Yeah.
It's the ether medium itself providing a stabilizing, buoyant response throughout the whole structure, like an invisible scaffolding made of pressure.
That is the core UCBF conclusion. What astronomers have been interpreting as a dark matter halo is just the unavoidable specific pressure response of the universal ether to the huge mass deficit created by the galaxy.
So by making the vacuum a physical medium,
the need for some exotic, non-baryonic dark matter to supply the missing gravity just vanishes. The gravity is supplied mechanically by the background fluid.
we've laid out the ether as this mechanical foundation for gravity and quantum mechanics. But the real test, for any theory of everything is the mathematical rigor. Can it solve the big unsolved crises that the standard model and GR can't touch?
Absolutely. And the rigor here starts by grounding the UCBF in high-energy physics. The theory is derived from the low-energy limit of 10-dimensional E8 by E8 erotic supergravity.
Which is a big deal.
It's a huge deal. It means the entire mechanical framework we've just talked about, the pressure, the density, the fluid, it's all a direct manifestation of a known geometrically elegant structure from string theory. It maps that high-level geometry onto a mechanical reality we can actually picture.
Okay, so let's test that foundation. Let's throw the three biggest headaches in modern physics at it. First up, the hierarchy problem.
Right, the ultimate riddle of scale. Why is gravity so ridiculously weak? Why is it 16 orders of magnitude weaker than the electromagnetic or nuclear forces?
It's this enormous gap between the Planck scale, where quantum gravity should live, and the electroweak scale, where the other forces unify.
And for decades, physicists have had to fine-tune their models with absurd precision to explain that gap, which usually means your theory is broken.
So how does UCBF solve this?
It solves it naturally, geometrically, using the 5D structure of the ether itself. It uses the Randall-Sundrum warped geometry model. In this model, gravity is essentially diluted because it has to spread out across that compactified fifth dimension.
Can you help us visualize that? How does a fifth dimension make gravity weak?
Okay, imagine the 5D space is like a long, continuous wedge. The ether density is incredibly high at one end. We'll call that the UV brane. That's where gravity is immensely strong. But our observable 4D universe, the IR brane, sits way down at the other end, far down an exponential curve. The ether density, and therefore the pressure it can exert, which is gravity, gets exponentially weaker the further you move from that high-density boundary.
So the reason gravity feels weak to us is just a matter of location. We're living at the low pressure end of the ether.
That's it, exactly. We're standing where the fluid is thinnest, even though the total energy of the fluid is enormous.
This huge gap in forces isn't a coincidence.
It's a direct consequence of our position within the 5D ether fluid and the curvature of that space. And the theory successfully derives the Planck mass, about 2.43 times 10 to the 18 GeV, directly from this mechanism. The weakness of gravity is literally built into the geometry of the ether's distribution.
That is an elegant solution. Okay, next headache, the cosmological constant problem.
This is maybe the single greatest failure of prediction in all of physics.
It's the mismatch, right? If the ether has that enormous baseline density we talked about, that 10 to the 17 GeV to the fourth number, Why is the actual measured vacuum energy of our expanding universe so close to zero?
Exactly. The theoretical calculation from quantum field theory for that vacuum energy it's astronomical. The bare vacuum energy, lambda bare, is cited as being around 1.47 times 10 to the 63 GeV to the fourth.
And if that were real?
The universe would have ripped itself apart in the first femtosecond. But we know the measured value is tiny. The difference is something like 120 orders of magnitude.
So how does UCBF cancel out this colossal energy without resorting to the impossible fine-tuning that standard physics needs?
It uses a mechanism called flux sequestration.
Okay.
It uses a higher dimensional field, a four-form field, whose flux is mathematically quantized. It acts like a dynamical counter-mechanism. The theory imposes a mathematical constraint that says the energy from all the heavy quantum modes must exactly cancel out that bare vacuum energy.
So it's like using an invisible mathematical counterweight to pull that 10 to the 63 all the way down to zero.
And the counterweight isn't arbitrary, it's quantized. This four-form field stores energy by being wound up. And to get that perfect complete cancellation and make the vacuum stable, the theory calculates that this field has to have an enormous integer winding number.
Integer. How big are we talking?
The theory calculates this integer has to be, well, approximately 1.23 times 10 to the 93.
Wow.
This colossal integer acts like a fixed topological charge that exactly offsets the raw energy. It's a stability condition. The universe is stable not by coincidence, but because of a massive, quantized geometric constraint.
But wait, if the cancellation needs a number that specific, that immense, 1.23 times 10 to the 93, doesn't that just move the fine-tuning problem? Instead of fine-tuning energy, you're fine-tuning this gigantic integer.
And that is the essential trade-off. In the standard model, you have to arbitrarily set a parameter to 0 with impossible precision. Here, the vacuum is dynamically stabilized by a mechanism that depends on a specific topological invariant.
So it's a feature, not a bug.
The theory argues this enormous integer isn't a free parameter you get to pick. It represents the total flux available within the geometry of the compactified 10D space. The universe is locked in place by this inherent topological property. It moves the problem from arbitrary precision to topological necessity.
Solving those two big cosmological crises is impressive. But a theory of everything also has to, spit out the actual ingredients of matter, the standard model particles. Can the Aether framework derive their properties?
And this is one of its most compelling achievements. The UCBF connects the particles we see directly back to the symmetry group structure of that 10D supergravity it comes from.
Let's start with the generations of matter. We see 3. Up, down, charm, strange, top, bottom. Why 3?
The 3 generations emerge naturally when you decompose the underlying 10D symmetry group, the E8 by E8 group.
When you compactify the dimensions.
Right. The colossal 248 dimensions of the E8 group break down. And the calculation shows that the low-energy spectrum must contain the mathematical structures that give you exactly the particle content of 3 standard model generations. It's a derived necessity from the geometry, not an input.
What about their masses? Why is the top quark almost 4,000 times heavier than the charm quark?
That hierarchy is explained by the 5D overlap mechanism. Remember how the ether density varies exponentially across the 5th dimension?
Right, because of the warp factor.
Well, the standard model particles are treated as the wave functions of these 5D vortices.
So different particles have different profiles, different locations within that 5D space.
Exactly. Some particle wave functions peak closer to the high-energy UV boundary, where the ether density is highest. Others peak closer to our low-energy IR boundary. The mass a particle gets is determined by its overlap integral, how much of its wave function intersects with the massive background ether density where we are.
So a particle whose wave function is near the high-density end experiences more ether pressure and gets a bigger mass.
Precisely. The top quark is so heavy because its wave function is tightly confined near that high-pressure UV boundary. The lighter quarks are more spread out, peaking closer to our low-pressure end.
The numerical success of this it's pretty incredible.
It is. Using this framework, the UCBF accurately predicts the top-to-charm quark mass ratio to be 4217.
And the experimental value?
That value is cited as being within 0.1% of the observed value. That level of precision, derived from the core structure of the vacuum, is a powerful validation.
And it even derives one of the fundamental constants.
Yes, the fine structure constant, alpha, which governs the strength of electromagnetism. It's derived strictly from the group dimensions of the E8 symmetry group itself. The calculation, based just on the ratios in the algebra of E8, gives you about 1 over 137.036.
It's a perfect match.
It confirms the framework can successfully translate these high-level algebraic structures into the core physical realities we measure every day.
Okay, so this theory gives us a unified mechanical basis for gravity. It explains the quantum shift, it resolves huge cosmological paradoxes, and it derives the Standard Model.
What does it say about the weirdest objects out there, black holes, and most importantly, can we actually test any of this?
Let's take the black hole problem first. The great theoretical flaw in classical general relativity is the singularity.
The point of infinite density where physics just breaks.
And where information disappears, leading to the information paradox.
But if the ether is a physical medium, and all matter is just a vortex in it, can anything really collapse to an infinite point of zero volume?
It can't. And the reason is the principle of maximum ether compressibility. The ether is hyperdense, yes, but it's still made of discrete, tiny grains defined by that Brent ether mass. And like any physical medium, there is a fundamental limit to how close you can pack its components.
The ether itself provides a natural hard stop for gravitational collapse. It does. A black hole in the UCBF model isn't a singularity. It's a stable droplet of maximally compressed ether. The concept is often called a fuzzball in quantum gravity circles.
So it has a finite size, a finite density.
And no infinite values. This immediately resolves the information paradox because information isn't crushed into zero volume. It's stored on the surface and within the finite compressed core.
And the theory must give a minimum size for this fuzzball.
It does. The derived fuzzball radius is calculated to be about 1.94 times 10 to the negative 13 meters. It's incredibly small, but it's finite. And that prevents the mathematical singularity and replaces it with a super pressurized ether condensate.
A really clean physical solution. Okay, now for the big one, experimental verification. For UCBF to really work, it has to make unique, testable predictions that are different from what we already know.
The main target is detecting the ether itself. The theory predicts that the speed of light, which is really the speed of sound propagating through the ether fluid, should be variable. It should be dispersive in high gradient environments.
Places like
near colliding black holes or neutron stars, places with a highly non-uniform ether density.
But how would we see a variable speed of light? It's supposed to be constant.
If the ether is a physical fluid, it has properties like viscosity and compressibility. And that means that different frequencies of waves will travel at slightly different speeds. That phenomenon is called dispersion.
And gravitational waves are the perfect probes for this.
They're ripples in the ether density itself, so our gravitational wave detectors like LIGO and Virgo should be able to spot this.
What would they be looking for?
The theory makes a specific mathematical prediction for a dispersion relation deviation. It would show up as a subtle, high-frequency shift in the gravitational wave signals. Detecting that kind of frequency-dependent speed shift, where the vacuum behaves like a dispersive medium, would be direct, empirical proof that the vacuum is a physical fluid, not empty space-time.
That would be game-changing. It would turn the ether from a concept into a verified substance. What about tests we can do here on Earth?
This leads to the prediction of the radiant scalar mode. Remember the radiant?
Yeah.
The 5D field identified with the ether density?
Yeah.
Well, if the ether is elastic and can be compressed, it must have a natural breathing mode, a scalar oscillation of its density. And that oscillation should show up as a detectable particle, the radiant.
So if the ether breathes, we should feel that as a tiny, non-standard force.
Correct. The UCBF calculates the mass of this radiant particle to be extremely low, around 3.10 times 10 to the negative 12 electron volts. Because it's so ultralight, it mediates forces that are incredibly weak, but act over macroscopic distances in the micrometer to millimeter range.
That sounds exactly like what precision torsion balance and Casimir force experiments are looking for.
They are the best candidates. Torsion balance experiments search for tiny, non-gravitational fifth forces. An interaction from this ultralight radiant would be a unique, measurable signal, a deviation from standard physics at short ranges that's unique to this framework. It gives experimentalists a definitive low-energy target to shoot for.
And finally, we talked about quark masses. What about the ghostliest particles we know, neutrinos?
The UCBF suggests that neutrino masses, which we know are tiny but not zero from oscillation data, also come from that 5D bulk overlap mechanism.
Oh.
But instead of their wave functions peaking near our low-energy boundary like the electron, or the high-energy boundary like the top quark, the source material suggests their wave functions have a complex profile that's shifted slightly towards the UV. the high-energy boundary, relative to other leptons.
If they peak a bit closer to the UV boundary, they'd feel a slightly higher ether density than the electron, giving them their small but finite masses.
Exactly. This specific geometry provides a mechanism for how the three neutrino flavors get their mass hierarchy, and it does it in a way that's consistent with the current data. Crucially, it provides a unified origin for the masses of all three generations of matter, linking them all back to the density profile of the background aether.
So this deep dive has really revealed a radical, but also mathematically precise new framework. I mean, the core earthquake here is replacing abstract, empty spacetime with a physical, mechanical, hyperdense ether.
It's a huge shift.
And that shift redefines gravity as a local pressure phenomena, a push, not a pull. And it connects the wild geometry of string theory directly to the dynamics of a universal superfluid.
And we've seen how it solves foundational crises. It resolves the hierarchy problem through geometric warping. It stabilizes the vacuum with that massive topological flux constraint of 10 to the 93. And maybe most compellingly, it successfully derives key standard model numbers.
That top charm quark mass ratio, 4217, to within 0.1%.
And the fine structure constant, all from the underlying structure and mechanics of the aether.
It's a theory that makes a really powerful final statement. All forces, all fields, all matter are just different kinds of motion, compression, and tension within a single, unified hydrodynamic medium.
And that holistic view leaves us with, I think, a truly profound final thought for you, the listener, to consider. If the ether is the fundamental substance, and matter is just a vortex within it, then the physical laws we see are just the conservation laws of this fluid. So what does that imply about the ultimate conservation of the universe? Could the total energy of the universe just be the total conserved compression state of the ether itself, held eternally stable by that immense topological constraint?
So mass and energy aren't fundamental things.
They might just be facets of the aether's own momentum and stability. If the vacuum is a massive, tangible substance, our most basic concepts might need rethinking.
A mesmerizing prospect for future discovery. Thank you for joining us for this deep dive. We'll see you next time.